Hi everyone, welcome back. Just seeing the music is... There we go. I've just realised I've been streaming without the music, I think. Okay, the music's gone quiet now. Cool, okay, that should be good. I'm going to turn it down just a little bit. There we go, great. Cool, hi everyone. Right, so it's been a while since we've done one of these, and I've got a plan for today. I think I'd like to create or work on the floor, because the floor looks a bit terrible at the moment. But just to remind us where we are, we'll do trunk serve. And come here, this is our game. Lovely website. So you see, we've got like the wall, and we've got our little men. We can zap with our little lightning bolts that we did last time. But the floor still looks really awful. And I think that's what I want to work on today. I've come up with a plan, and the plan is to make an actual full-size image, and then within the JavaScript that's generated, or the WASM, we're going to scale it and add perspective. And if I'm honest, I have no idea if it's going to work. I've not tried it. It's going to be interesting. And there's two stages to this. One of them is to make the floor graphic. And that graphic is going to be, so I think from my calculations, I need to make a full size, so the full game screen size, which I think is 800, but we'll check on that. Make a full like tile map of all the floor, and then basically scale it. So I'm going to divide it into chunks. It's going to start with 10 chunks and then scale up to multiple chunks so that we can try to create this pyramid effect going to the center point of the image and outwards from there. And obviously the center point part will be hidden, so it won't be an infinite corridor, but I'm going to get rid of all the other components first so that we can see it. And then eventually the wall will help to hide the fact that it's an infinite corridor, effectively. So yeah, that's the plan, and we're going to see how that goes. I'm just going to turn it down here, because there we go. Just the music's a little bit loud. Cool, so first thing, we're going to go to our graphics package and do new image. So what I thought was I would create some tiles. So the image is going to be, actually we need to check the size. So that's going to be on the game page, I think is where we created them. Oh no, they're in main. Game width and game height. So it's actually 800 by 600. I've got a little sort of diagram. I did a little bit of sketch. Okay, that's no good. We can't see that. I'll try to sort of recreate the sketch in Paint. So the idea is to start with a square image, and it's going to be 800 by 600. I'm going to fill that with tiles, and the tiles are going to be 40 by 40, so that we end up with this grid. And then basically what we're going to do, we can take the top and pinch it in and keep the bottom the same so that it ends up making a triangle, effectively. By starting with an image that's the full size of the screen, and then the idea is to take these chunks and scale them. So if we start with 10, and each one will be a 10% drop until the last one will be 0. And so we're going to scale it. So this will be 100%. This one will be 90% in both the width across and also in its height. So all of it's going to be crushed down. The next one will be 80%. The next one will be 70, 60, and so on. And I'm hoping that's going to give us like a rough perspective, so a little bit of what we're hoping to achieve, which is this triangle pattern where the details of the image get squashed the further up we go. And then once we've got it working with 10 different segments of this, then try and upscale. So we're going to write the code bearing that in mind. And again, I'm sort of improvising this all entirely as I go along, so it's just me making it up. So we'll have to see. I don't know if it's going to work at all. But the first thing is to get this tile map with all of the tiles on down here, and I'm going to cheat because I know I said I was going to do everything in Rust. I'm actually going to do this bit in Python, but the Python won't be in the final game. But I will commit the code into a folder. I will probably call it apps, and then you'll be able to kind of take the code and use it and repurpose it yourself. I think you'll see why when I do it, it'll be fairly obvious why I've chosen that, because it's just so it's so much easier than trying to do it in Rust. Rust isn't really designed for scripting and hacking. It's designed for writing very fast applications. So if I wanted to turn it into a full-scale application, Rust would be the choice. But to just run a script and have it generate an image, I think Python makes more sense for that. So we're going to call this VCC clone tile floor, because we'll also do the okay, I called it wizard game here. So I've created I've recently updated this thing, so you create collections now. It's going to be 40 by 40, and I will set the pixel width to, let's go with, actually, let's just jump straight to 4, I think, and then we can go to 2 if that doesn't feel right. But I think this is going to be it. I found a little bit of inspiration, so let's see if I can dig up the same thing. Pixel art tile floor. Yeah, here we go. This sort of thing I think looks really cool. So I'm hoping to copy this, and of course it looks a little bit like the back wall as well. Similar kind of sandstone color. So go with that. Yeah, there we go. Okay, let's create this and see what happens. Okay, we get an error, unknown root. Okay, cool. Well, that's not going to work because it turns out I may have broken the pixel application. That's great. Okay, so that's just the sort of technical disaster that we wanted on stream. I can't really think of an easy way around this for the stream, unless we also use Python to create the tiles as well. Okay, yep, let's do that. So I will bring up a hex color picker, because we will need these values. So that's, Google has this kind of built-in one, which is kind of cool. So let's let's open a new terminal here. Go into apps, and we're going to make a directory, and we'll call this floor tile maker. Floor tile maker. And then I will touch yeah, we'll call it gen tile single. And I will actually go up, and in the apps I'm going to create a virtual environment in here to store all of the libraries. If you've not used Python before and not used virtual environments, I definitely recommend it, because it helps keep your libraries isolated. Activate. Yeah, forgot that I'm running bash in here. So, okay, now I'm in my, yeah, so if I do which Python, we can see it's inside the virtual environment, inside the scripts folder, which means it's using the one from the virtual environment, not the global one. And I want to do pip install, and I want to install Pillow, the image manipulation tool, which is cool. Okay, and so we have our gen single tiles. So let's import PIL as pill, I think, and do if name equals main. Again, this is just, this isn't really what I wanted the stream to be about doing Python, but this is effectively like creating a main entry point like you would in Rust. It's a good idea in case you accidentally pull, or you might create, as your code grows, you can create functions that maybe you want to pull into other scripts. If you import and you don't have this guard against it, it will run any code that's just in the root, which can be useful when you're creating modules, but really you want to, so if you're just running the code like this, you probably want to isolate them, so that's what I'm doing here. So, so starting to generate tile, okay. And so we want to create PIL, do image is equal to PIL dot create. Actually, I'm going to have to Google this. It's been a while since I've done pillow stuff. Look at that. I had the page already open. Gives a bit of, I was doing a little bit of background. There we go. We actually want to do from PIL import image. That's what we wanted to do. It's image new. There we go. Cool. And just Googling the, or looking up, sorry, the thing. Okay, Python pillow image new. I just can't quite remember the parameters that go into it. The mode and the size. So the mode is going to be RGB. Do we need a transparency? I'm going to put a transparency in, just in case. And then the size is going to be 40 by 40. Okay. And then we're going to, what did we say? The pixels are going to be 4 pixels across. So create a const for that. Pixel width equal to 4. For x in range 0 to 40 step pixel width, and then for y in range 0 to 40 step pixel width, I'm going to say image dot set pixel. Is that? Sorry, just looking up the. That might be why I wasn't coming up. Okay, it's not right. So just going back to my page again, Python pillow set pixel. Put pixel, there you go. Okay, put pixel, and the first one is a tuple of the x and y coordinate, and the second one is the color that you're putting in there. So we'll do put pixel, x, y, and now we go back to our color picker, which I've lost somehow. Color picker. Okay, we want to go for a sort of dusty sandstone. I wanted, yeah, a nice sort of warmish color. I think that's good, and then I'll go with a grey for that. So I'll just copy and paste the color here. And we want to do for I in range 0 to pixel width. Yeah, that's what, yeah. And then for j in range 0 to pixel width, we then want to put the x and y plus the I and j plus I and plus j to shade in all the pixels around. And we also need to put in because we've made this an RGB. Actually, you know what? I'm going to just make this an RGB because I don't think the floor needs to be see-through. So it's just going to be that. So we'll go floor tile maker, gen tile single. Okay, did not like that. Range takes no keyword arguments. Okay, so it's not a named. Okay, so that, okay, it, I didn't save it. Tile1.png, and there we go, we've got our tile. Cool, so that's our first tile, but obviously we now need to actually put some decoration on that. So the grouting at the edge, and we're going to go. So I think it might be worth doing a second pass, maybe. Actually, let's just do it directly. So let's get our darker color for the grout. Let's go with this one. Just put this here for now. So if x equal to 0 or x is equal to the width, so it would be equal to 39, oops, 39, or y is equal to 0, or y is equal to 39, then we want to put pixel there. Take the darker color, else do this. Okay, this should leave us with a bit of a border around the edge. So we come back here. Okay, almost worked, not quite. Oh no, it won't be. It'll be 40 minus, so it's 36, isn't it? 40 minus the pixel width. There we go. Okay, so we've now got our grouting, and that looks kind of cool. Then we want to create, I'm going to pick a slightly lighter color that's sort of in the middle. Use this to do some sort of randomized stuff. I'm going to import random. Int 0 to 100. What? That is very unlikely. Okay, that was just incredibly unlikely. It just happened to pick 100 the top value. Just try that again. Okay, yeah, that's working. Right, so I'm going to say that we get a 10%. Just call it R. Random.randint 0 to 10, and L if. Oh no, hang on, that's not right. We want that to be within here. Go L if R is equal to 1, let's say. Then so this should give us a roughly 1% chance. That in there, and then we've got a slightly middle color here. Put that in there. So just exit. Okay, cool. And yeah, we've got some random like shading in there, and actually just going to rename this so we can keep it. Tile1 X for experiments. And I'm going to turn this into a function, create tile. File name. And then we're going to do file range in range to, let's say 10. We'll just create 10 different variations of the tile. We then want to call, what do I call it? Create tile. Create tile I. Okay, that should now run this 10 times and create us 10 different tiles. Yeah, so tile 0. Nice, that has worked exactly as I'd hoped. It's got us some random like spotting. There we go. So that works for me. So we now have our random tiles. And now we're going to be creating a new script called this gen4. And we'll just copy from PIL here. Do the if name is starting floor generation. So the first thing we want to do is create a new image. The mode is going to be RGB, and the size is going to be 800 by 600, I think. Oops, 800 by 600. It does not like that. Why? Because we need to be separate. Okay, cool. So we've now got our output image. And so then for x coordinates in range, and again, I'll just copy over actually we'll call this tile size is equal to 40, in range 0 to 800 with a step of tile size. And for y in range 0 to 600 tile size, then we're going to have to pick a random selection. So we going to need import random again. Random.rand int. Between 0 and 10. So this will give us the file name. The file name is going to be equal to do fstring tile r.png. Then we going to call this next tile. It's going to be image.open file name. I think that's all we have to do. And then for copy x in range 0 to 40, actually, just say for tile size, and for cy in range 0 to tile size, then we want to get the pixel. So that's going to be next tile dot get pixel. Yeah, there we go. And that needs to be a tuple of cx and cy. And then we want to do on the output image dot put pixel. So we've taken the sample from the input image, and we're now going to copy it over to the output image. So that wants to be x plus cx, y plus cy, and we'll just pass in the pixel. So this might work. Let's see what happens. So what do we call this? Gen floor. Okay, doesn't like that. Did not like. No such file or directory. So it should. this is quite surprising. It should have floor tile maker. I mean, it's there. No, it's not, because it tried to give us. Okay, that's. Oh yeah. So the reason is random int will. Did it even create a? Oh no, we never saved it. im.save floor. Oops. Floor.png. Okay. Let's just call it floor tiles. So yeah, random goes up to and including the second number, whereas range doesn't, which is why it didn't work. No, I'll just call it floor. Sorry, I'm having a bit of a indecisive day today. Hey, there we go, and voila, we have our floor. So there we go. That is what we're going to do, or what we're going to start with. It's not perfect. I was hoping to use the pixel art generation tool, but hey, it gives us something, and we can work with this. So we want to now copy this out into assets. That's where we want to go. Yep, images, and we already have a floor. I'm kind of curious. I'm going to rename this. Look at that beautiful image before. I remember hand drawing that. Call this floor old, and then I'll copy this in here. And then I'm kind of curious what happens when we run trunk serve again. I need to rerun it so that it copies the assets across. So we go to 127. Oh, it has not worked, and I suspect I know why. We need to clear the cache. So to do that, go to history, clear recent history, clear the cache. There we go. Okay, awesome. Well, that's like kind of working. Obviously, it looks horrendous, but once we start crushing the thing in, it will work. The reason it's offset is because it's currently drawing it where the original floor was placed. So if you imagine the original floor image was here. So yeah, it's using all the old dimensions and stuff. But that's cool. It's reading in the new image, so that's great. So now we have to go back and find the code. It's always a bit risky. Oh, we created a whole wall type. Did I create a floor? How did I draw the floor? Let's have a look. Floor.png. Bottom wall image name. Okay. Right, interesting. Yes, I created an enum. Okay, okay. So what I'm gonna do, oops, self dot. Ooh, okay, yeah, we're not actually storing the. Oh, we are. Match wall type. Ah, okay. Do we store wall type? Oh, we do. Yeah. So if self.wall type equals wall type bottom. There we go. Then we will call self. Actually, let's leave it. Let's leave it like this. Else draw this. So we'll leave the old way of drawing for this, and we'll figure out the pattern so that we can just make it one later on. But for now, if I leave this like this, it should mean the floor disappears completely. Oh, hello, we've got a error. Right, it doesn't like that because partially Q is missing from the enum. Okay, so this is because we're trying to derive. Yeah, it is. So you have to include partial EQ in here. Is it like this? Sorry, having an absolute brain fart today and cannot remember the syntax for derive. Yeah, gosh, that was well off. There we go. Let's never do live coding. Right. Okay, anyway, that should hopefully allow us to do the comparison now, and it does. So cool. So it automatically refreshed, and we're now missing the floor, which is great. That's what we wanted. So we now want to get the create a const. Call this number of segments, and it will be an I32. Actually, it should be U32 because it's unsigned. And we will say, actually, I'm going to start with 4 because I think that'll be nice and easy to see. So we're then going to say the for 0 to segments, number segments. Yeah, so we want to do this, and we want to calculate the percentage that we need to do. So frac is going to be equal to I as F64 divided by number of segments as F64. And the reason we have to do the conversion before is because otherwise we'll lose the decimal point. So we now have a fraction. This will be between 0 and 1, which is the amount that we are doing, meaning that I needs to be the bottom piece because I needs to be the top piece because it will be 0. No, hang on. So this will give us 0, 1, 2, 3 in the numbers. So I'm going to put a little fiddle factor in here. Do if. So make if I equals 0, else return this. And the reason is because I don't want to have a 0%. I still want a little bit of it. So I will return 0.1. We'll just make that. Yeah, we'll make it that for now. And we'll let actually return, and that needs a comma there. Cool. So now we have our thing, but the bottom one, the top one, won't be 0, so it won't completely disappear. It'll still be there. So we then want to, for this, do we? Yeah, we have an x and y. Okay. Yeah. So we'll use the. So the x coordinate is going to be the center of the image minus 2. That's probably correct. Yeah, the x, because the alignment is correct. Ah, no, the x is going to need to be the new width of the item. So let's copy this in, and we'll just do, excuse me. Sorry, very froggy throat today. So the input is going to be, yes, we need to calculate the SX and SY. So SX is always going to be 0 because it's always going to be reading in from the left-hand edge of the image. The SY will be the fraction. That's SY equal frac times the image height. So that's the offset there. The input width and input height will be that, and the output will be for now, I'll just leave the x, and the y will be y minus. We can reuse s. What? Why is this not F60? Is this F64? Oh, that's U32. Okay. 64. Okay. Okay, that's better. So now it's coming back as an F64, which it should have been before. So the y is going to be let y uy equal y plus. No, it's y. Yeah, it's y plus because we're going. Actually, I'm really curious. I'm going to go back to the main page just to see what the original place where we created the walls. Game width over 4. Oh no, the bottom. Here we go. Game width over 2 and game height 0.75. Okay, I'm just going to draw that. Actually, I should probably draw it on the diagram. So, does it want to be that? I suppose it does, because logically that's the center of the floor. So 3/4 of the way down would be the center of the floor here. So that would be correct if we were still using the triangle shape. Do we want to specify that? Does that make sense? Or would it be better to start from here? I think, actually let's specify the start position. So let's say that this is going to be game height over 2.0. So it's going to start from the very center of the image, meaning that we now need to calculate. So we want to lose this, so that we're starting from the center of the image. Okay, actually that's. Okay, we'll just. I don't want to disrupt the the other code, because otherwise the walls and ceiling will disappear. So we start with. So we've got the center of the image. We want to add I times sy as F64. Oops. Yeah, there we go. So this should give us our new y. And we're leaving x the same. Actually, we could. Let's have a look at this and see what's going on. So this is that times frac and that times frac. So this should produce a very interesting effect. I honestly have no idea what it's going to do. Okay, it's kind of, yeah, it's coming in. Okay, so what it's done is taken the whole image. So we need to make sure that the input height is times frac. So we're only reading in the fraction of the image. Okay, that looks a little bit better. It's a little bit skewed because the output width is not quite right. Because we need the new x here. We need to calculate the new x. So new x is going to be equal to self.lock.x minus the self.image.width over 2 and all of that needs to be multiplied by the fraction. Except it doesn't like that because it's not an F64. Okay. Okay, well, it's centered, so that's a good start. But obviously everything else is a bit messed up. So yeah, I've realized that it's because it's still starting from the Y and just adding the different bits. And actually what we want is to maintain a cumulative distance, not the segment. So, so starting from 0, let mute cur y equals 0.0. And then for each new y, we're going to add cur y plus equals the new y. And then so we're going to do that after the draw. And then the new y is going to be this plus cur y. Oh, actually, yeah. Yeah, that's what we want. Yes, and then we update cur y to be yes. Okay, that is. So hopefully they should be stacked on top of each other now. Okay, they have kind of, but not really. Okay, I remember I said I was going to get rid of everything from the game, so we will go to the draw. We want to we'll get rid of the back wall. We'll get rid of the enemies and any fireballs and lightning bolts. Okay, this should strip away all of the stuff that was sort of getting in the way, really. There we go. Okay, so we've now got this, and I'm not really sure what's going on with it. Yeah, that has not worked at all. So let's go and revisit the maths on that. So let's follow it through. So it comes in as 0. So we know this is the first segment, and this will be 0.1. Yeah, maybe we should do this from 1 to +1. And that's going to be easier, and then we can just put this back to how it was. Okay. Okay, just refresh and see if this fixes all our problems. It does not. It does something else entirely. So, okay. So we come in with 1, and 1 over number of segments is 0.25. So let's make some notes. Okay, so the fraction is 0.25. So this means that our image height, oh yes, of course the input, the reading input will need to be off. It doesn't explain why the output's wrong, but yeah, so we also need to maintain the current y, the current sy of how much we've read in, or do we? No, we can calculate that. So that will be yeah. Segfrac is going to be 1.0 divided by number of segments as f64. Yeah, so the segfrac will give us the input height of each. Oh, sorry, the number of one, the fraction of one segment. So that segment will be, so our sy is going to be that multiplied multiplied by I. There we go. So actually it needs to be I minus I as f64 minus, so we'll do I minus 1. Yeah, we didn't even go down because we want it to be 0 for the first one. So the offset will be 0 on the first go through. and the fraction, oh no, we're back, yes, the fraction will be 1 over, so 0.25, okay, and sy will be 0 on the first go through, and then uy will be the location.y, which is the center of the image, plus I minus 1. Oops, I minus 1 is f64 multiplied by sy. What was sy? It's going to be 0 on the first one, so it's just going to be self.lock.y, okay. And then the new x is going to be the fraction. So we have self.lock.x, which is the center of the image, minus the image width. Oh yeah, that's totally wrong, isn't it? Multiplied by the fraction, so a quarter of the image. New width is going to be equal to self.image width as f64 multiplied by the fraction. Oops, see daisy, that's so wrong. There we go, and we want to go, it's the location x minus the new width over 2. Yeah, okay, cool. New x, new y, right. And the draw width will be the new width. And we should also calculate the new height. Which would be so it's the offset multiplied by the segment fraction of the input heights, so that's sh, so that's the sh multiplied by the scaling factor. So the new height will be sh multiplied by fraction. Yeah. And it is the new height that gets added to the cur, yeah, so that should be cur height. Cur height. It's the new y, yes, the, oops, cur, because it's the current height and not the current y. So let's have a go with that. Let's see if that works. Okay, well, that's a little bit better. Suspect. Yes, this needs to be SH. There we go, the input width, so that's a good start. The draw X is the new X, the draw Y is the... Oh, hang on. Should that even be that? That should be current height, surely. Okay, we're getting there. This is a good start. It's not quite there. Not sure why. It'll be because the current height starts at 0, adds those stepped values on. So it should start at self.lock.y, because that's what we said. So that's going to be the starting position. Hey, this is starting to come together. Right. It's starting to come together, but this is still looking very, very stretched for some reason, and not really sure why. going to try just, why is new, yeah, so new Y I think we can ignore because we're not using that. Okay, I'm going to try upping the number of segments to 10 just to see if it actually improves anything, because 4 isn't a huge sample size. Okay, that's like sort of getting there. Try setting it to 100 just to see. Oh, that's interesting. We've got a rounding error somewhere, just giving us this interesting curve, rather than a linear thing. But it is kind of working. So yeah, so I suspect this rounding is coming from is coming from a rounding error. But actually, now that I've stuck it to 100, it's working, and it's also giving a nice little pixelated thing, which kind of fits with the pixel art style, which I'm actually quite liking. So the only thing we have to stop, we have to try and make this a bit straighter. Actually curious if I go with, how tall is the image? It's 800, isn't it? Let's try going with the, curious if I go down to 50. I'm really curious what's going on here. Okay, we've still got that curve. Okay, so I think it is definitely a rounding error. But the 100 lost the blur. So let's go back with that. And yeah, okay, so try and figure out where our rounding error is coming from. If there even is a rounding error, there might not be. It might be kind of inherently built in. It's doing everything in F64. We want to read in the width and the start heights. Sorry, just thinking. At the moment, so yeah, it's. I have no idea where that curve is coming from. Sorry, I'll show you what I'm looking at. I have no idea where the curve is coming from, because it should be 100% here, and about halfway down, it should be 50%, and then it should be 0%. And so that should be 25%. So I think maybe this is, because this is like a fisheye effect. I'm wondering if actually I've got it wrong on the way that perspective works, and that my assumption is too simplistic on trying to make the perspective work. And how I might even go about fixing that. Because it feels like I need to be just needs to get thinner a bit faster, really. It feels like early on it doesn't reduce enough. And maybe we could try and flatten this edge a bit. So let's oh, actually, no, it gets bigger too fast. So right, so what I'm doing is I'm racking my brain to think of a way of applying an algorithm to or an algorithmic interpretations, instead of using the fractions of like 1 over the distance, that we use yeah, or could try like splitting it in half. I'm gonna just try randomly multiplying this by itself. This is me absolutely just stab in the dark, no idea what's going to happen. Okay, and it gets more linear, which is even weirder. Although you get this weird blur at the front. I'm going to try cubing it just for the hell of it. And then it gets even flatter. Madness, but we still got this weird blur at the front. Okay, well, I think I like the squared one. If anyone watching this has any idea why why the maths I've written is doing this, I would be really interested. But that definitely is weird. And then we've got to figure out what's going on at the end here. So, because that is a very skewed bit at the end. So I'm gonna okay, what I've done, I'm gonna load the console so that we can see, and did I enable log? I did not, so we're gonna use glue console log just so we can print stuff out. And then I'm just gonna log all of the, okay, let's go with, oops. So I think this is to do with the input height. Oh. Okay, yeah, I bet it's this line here, isn't it? That's doing the. Okay, let's have a look at that. And it'll be the last one that's drawn because it goes from the middle outwards. Just finish waiting for this. Oh, it's going to redraw every frame, isn't it? Yeah, of course it is. Okay, so that's no good. Okay, that logging's not going to work very well. So instead, I will go with if I equals the number of segments, then we will log. That should give us one value. Yep, here we go. So 497. What's the 497? That's the offset. Okay, yeah, that's probably right. So 497. Oh no, that's off the bottom of the. would it be? Because it's 300 is the middle. So yeah, 497. Okay, I don't know where it's getting that from, but it should be. Okay, and it thinks the image height times fraction. Okay, so the fraction is 1. Oh, that's why. Because it should be the yes, because the the sh, the read in should be 6. Yep, that's correct, because it's 600 high and there's 100 segments, so each segment should be 6. So it's the image height. Yeah, this all breaks down because it's okay. This actually may be where the curve is coming from. So the fraction. Okay, let's put this back to where it was and see what the numbers do, because that. Oops. Okay, and then get the output values. Yeah, so it's doing the output height times the fraction, which is not right. It should be the segment size, segment height. That's why. Yeah, the draw height should be the segment height times the fraction. Oh, wait, I never put, for God's sake, never actually applied the new height. Okay, well, that's given us an interesting, I don't know if it's coming across on the stream, but there's like white lines in there, which suggests that this actually is working now. Because I think it's a weird drawing artifact. It's like drawn over. I'm going to reduce these back to 10 now, the number of segments, see what that does. Okay, well, that's definitely looking more like it. Not liking the bottom segments hanging off a little bit, but that. Okay, so if I go to, it's still got that curve effect though. I'm wondering if it's. In this white line, I don't know where the white line's coming from. Does everything else line up? Yeah, it feels like everything else lines up and it's kind of reading in. Let's see, number of segments. So I'm going to get the calculator out. So let's go 600 divided by 40. It's 15. Okay, so that should be. So there are 15 tiles going down on the side. So this should be 1 tile per strip. Okay, that's working. But we also have our white line in there, and I don't know where the white line's coming from. Okay, so let's try and figure out what the second one would be. So the first one will be So, so the segment fraction is 1 over number of segments, so that will be 1/15. Okay, 1/15. Maybe this is easier if we go back to doing tens. So I'll just bring that back up so we can, yeah, you can slightly see the curve. Okay. So the first, okay, so the first one is 1/10 or 0.1. Okay, and the fraction, take that off so we're not mutating. So the first one will be 1 over number of segments. That will also be 0.1. Okay, so 0.1, 0.1. So the fraction, this will then be the image height times 0.1. So we've got 1/10 of the input image. That's correct. The SY will be, what's the SY? It's the start Y. Okay, yeah, that's fine. That's the offsets from the, yep, so that's 1 or 0. Sorry, because it's starting from the top. The new height would be the starting height, so 60 multiplied by the fraction, so that would be 6. So the first one is going to be 6, and the new width is going to be the whole image width multiplied by the fraction. I know where the difference is coming from. Okay, yeah. Yeah, okay. It's the aspect ratio, because the width needs to be multiplied by the aspect ratio. Which should be 600 divided by 800. I think. May have gone the wrong way with this one. Yep. Is that linear? I don't feel it is. Also, it's overflowing, so no, it must be. Yeah, I didn't think about the aspect ratio. Well, there's a simple way round with this, which is to simply make it. Yeah, let's experiment with making the floor 600 x 600s, and we'll go 600s, and that also needs to be 600s. Floor 600, 600. Okay, yeah, so let's start with this, and then we'll put the floor 600, 600 in here. And game, no, wall, isn't it? 600 x 600, okay. And then get rid of the aspect ratio correction. This probably won't reach the floor now, I think. That didn't work. chunk serve. There we go. Okay, yeah. So it's now never going to be wide enough. So what we actually wanted was 800 by 800. Yeah. Dope. So where are we? Gen floor, and we're going to do 800 by 800s. Nope. Back wall again. 800, 800s. Okay, it kind of works, but I suspect we need more segments. So let's go back to hundreds. Oh gosh, that made it even worse. So that problem is because we're okay. Really thought that was going to do it. The aspect ratio is definitely a problem. And everything we've done up until now has been I'm guessing it's not quite reaching the floor because it's trying to draw 400 pixels stuff into I think I might know what we need to do, and that actually you multiply. Yeah. Okay. Gonna try one more thing and then call it a night. I will save this to its own branch so that if you pull the code, it's not in the thing. Oh, hi. Hi. Sorry, everyone. I had the chat off to the side. I didn't see those come in. But yeah, thanks for stopping by. Thanks for subbing. Cool. So, yeah, this is a really weird issue. So I think what we need to do is calculate like the fraction of change per thing, and then just keep multiplying it by itself as we go up the steps, as it were, of the pyramid going in, and that. See, that feels like that would give you a curve if you just keep exponentially doing that. But then maybe that's what we're doing. Not sure. Anyway, we'll give that a go, and then, as I say, I'm going to call it a night. I'm getting a bit hungry, so have some dinner. So what do we want to do? Maybe we should start from the bottom actually and draw upwards. Yeah, let's do that. Walls push, okay. So we'll set the game height as being the start position for the bottom, and then segments. Okay, so the fraction is going to be the segment fraction. It's going to start at 1, and then each time multiplied by the segment fraction. Is that right? No. Maybe it's just minus equals, so that feels like it would be more linear. Okay, well, I didn't like that at all. Oh, yeah, because it's starting from... Yeah, all the maths is wrong. All the maths is wrong for that. So the y position is going to be the self. So it starts at self.log to y. So it starts there, and the output, the new y is going to be the current height. That's going to be this height, but that needs to be minus equals. I think this will be off by 1. Okay, that did something else entirely. Okay, I'm going to try doing 1 minus the segment fraction, just to see what that does, because I'm just really curious what's going on. It's linear. Okay, it's linear, but it's not going down fast enough, I would say. So it needs to squeeze in a little bit more. So how can we do that? Maybe try doing the segment fraction squared. Anyone that understands maths is probably screaming at the screen right now. Okay, that was not right. Is there a... I don't think there's a thing to square. So okay, we're getting somewhere now. That's looking a little bit better, a little bit more like a corridor. Let's see what happens. What happens when we just start multiplying by? Oh, look at that! That is very much closer to the effect that I wanted. Yeah, I am stabbing at maths right now. I have no idea. Ah, I've realised where the white's coming from. The lines, because I can see the outline of where the walls were. So that, yeah. So I think the floor looks really cool. I had no idea what will happen when we start drawing the little wizards on there, but it's because it's off by a pixel, I think. So I wonder if it's the current height minus new height. Minus 1. Nope. Needs to be a think this is going to skew it. Oh, I don't believe it. Is that all it was? It was just that I was adding. So I'm going to try removing this weird cubic function that I just added. Does that solve all the problems? Okay, it kind of does, yeah. Okay, we go back to the cubic function. Actually, I think let's try going back to the rather than having a cumulative fraction, just where we try and remove this off by one error. Let's go back to plus equals. I feel so silly now if that's what it was. And of course, because 1 pixel would make much more of a difference. Okay, right. I really should have saved this. So fraction. Yeah, I think everything else is the same. And that starts at self-block y, and then we just have to make sure that the y is over 2.0, so it starts in the middle. Okay, well, the white gap has gone, but the problem has been made worse. So let's try in the wall. Let's try adding the weird squaring factor in. Okay, that wasn't quite what I wanted. Let's try. It feels like it's getting flatter, but then the offset is. It's still got the curve in there, isn't it? Yeah. It's, oops. Okay, I think the other way was definitely better when we did this. I think we're definitely going to end up with some weird perspective in this, I think. Okay, that's even stranger that that's now dropping out the bottom. Go back to a single. Okay, so now it feels kind of linear, although we've got some weird artifacts here with this overdrawing, so something's not quite lining up. That might be the best that we get. And actually it looks fairly linear down to about here. So last thing we're going to do is just going to add the all of the items that I removed before, and we'll just see what it looks like. Where are they from the render? So we definitely want the back wall back. Actually not fireballs, because we removed those in the last game. Okay. Where's my window gone? There we go. Okay, that's... Yeah, that almost looks right. We can zap them still. Yeah. Okay, I will maybe consider making the back wall a little bit bigger, just to hide this error here. It's probably not a bad idea. Which would be in here. I think back wall's its own thing. So I will optimize over 2. New width is going to be equal to that multiplied by 1.1, and let new height equal to self.image height as f64 times 1.1. Okay, new width and new heights. Output. Oops. There we go. Look at that, covering up the mistakes by making the back wall slightly bigger. That's classic. So yeah, that's not a terrible outcome for today, given that I basically just wrote what I thought was competent maths on a whiteboard to try it out, and then sort of mashed it together in code. Yeah, I think these like double lines and things are caused by the offset problem, which I created on my own by doing this -1.0, so subtracting a single pixel from the height. And I can double check that by adding it back in, but then we will probably get the white lines back. Yeah, we do. But there, you see, it is linear again. So yeah, I added in one problem. I'll have a think about this. I suspect the new height I wonder if that was my issue, actually. Wow, it was not my issue. I've sort of created Rainbow Road there. But yeah, anyway, I'm going to give it a rest for now, because I'm just sort of randomly changing maths, which is never really a good idea. But it's interesting that created a more unlinear function. Yeah. Maybe, actually, I can, sorry, I keep having ideas as I go through. So if I do that, we get the white lines back, but it looks linear. Okay. But then, to combat the white lines, no, that's not going to work, is it? Or maybe add that back in. Yeah, no, I got nothing. So yeah, we'll leave that for now, and then we'll try to put the walls in the next one, and the ceiling, and then we can start putting the polls in, and then we can start working on the actual gameplay and trying to get these guys to move around in a more sensible location. But yeah, we can zap them, and we can also make them actually attack us as well. So thanks very much, everyone. Thanks, Ashes. Thanks, Floorman, for stopping by. And yeah, I'll wish you a good evening and a great weekend, and hopefully see you again soon. Yeah, take care of yourselves. Thanks. Bye.